What's up, guys? Today we are going to be doing A-level math paper 1, and it's the variant 11, May, June 2025. The last video I did on paper 12, you guys gave an amazing support on that, so let's just get into it. So the first question is from trigonometry, and it says solve the equation 6 sine theta equals 1 plus 2 over sine theta, and then they've given us the possible values for theta, which are negative 180 to 180 degrees. So let's just straight up solve this. So we're supposed to find a value for theta. That's what it means to solve this equation. So what we can sort of do is we can sort of just arrange everything, get it on one side of the equation, make it look a little neater. So let's just do that. So we can take this 1 over there to the other side, so we'll get 6 sine theta minus 1, and then we have this 2 over sine theta. So we can multiply this guy over there, and then we'll just get 6 sine squared theta minus sine theta equals 2. Okay, we can sort of rearrange the equation, and we'll get 6 sine squared theta minus sine theta, and we bring that 2 over here, so that's going to be minus 2 equals 0. So once we get everything arranged, get everything on one side, we can sort of see this is just a quadratic equation. How do we solve this? If you don't see it yet, you will see it in a second. So we just say that the sine theta is equal to, let's say, x. And now you'll start to see that it actually is a quadratic. So it's going to be 6x squared minus x minus 2 equals 0. And then we can solve out this quadratic. We can use the quadratic formula, a bunch of other stuff, whatever you want. I'm just going to use the quadratic formula over here. So this is going to be minus b, and b happens to be negative 1. So it's just going to be b plus minus 1 squared. So it's minus 1 squared minus 4 times 6 times c, which happens to be negative 2, divided by 2 times 6, which is 12. So this is going to be 2 by 3. X equals 2 by 3. And then x is also equal to, we can get the other answer for this if we go and change that sign to a negative. So change this sign to a negative, and we get negative 1 by 2. Okay, and now we're not trying to solve for x, remember, we were trying to solve for sine, so let's bring that sign back in here. We can say that sine theta is equal to 2 by 3, and that sine theta is equal to negative 1 by 2. Now, before we start to sort of, now you can see we can sort of find the value of theta, but before we actually do that, what I want you guys to notice is that the values allowed to us are actually these values. So if this is negative 180, it's negative 180 to 180. And this can be positive 180. So these are the values sort of allowed to us. If you start from 0, you can go all the way clockwise to negative 180. Or if, again, you're on 0, you can go sort of clockwise till positive 180. Those are the only two values allowed to us. So let's first do it for theta is equal to sine inverse of 2 by 3. And one thing to notice here is that since this is a positive number, we know that sine happens to be positive in two quadrants, this one, and we are allowed both of these quadrants. So we can sort of take the angle and take the inverse. Sine inverse 2 by 3, that's just going to be 41.81. So one of the angles is going to be this one, okay, and the other angle is going to be this one. So the first angle is going to be theta is equal to 41.81 degrees, and then the other angle is just going to be 180 minus this thing. So that's going to be 138.19, 138.19 degrees. Okay, and then you can sort of do it for that other value of theta is equal to sine inverse of 1 by 2. Okay, and then this 1 by 2 was negative, so we know that sine is going to be in the negative quadrants. We got two quadrants where sine is negative. It's this one and it's this one. So let's get our calculator, put in sine inverse of 1 by 2. That is going to be 30 degrees. So we're going to get 30 degrees over here and another over here. And then this time you can't go clockwise, right? This angle will be greater than 180. But what you can do is you can sort of go anti-clockwise. And then what's going to happen is this is going to be your first angle. This is going to be theta is equal to minus 30 degrees. And then your other angle is going to be this guy. So we can sort of do 180 minus our answer, which is 150. So this angle is going to be negative 150, which is negative 150 degrees. So these are the possible values for theta. Moving on to question 2, it says that the equation of a curve is such that its derivative is equal to this, and it also tells us that a curve passes through a point this. And what we need to do is we sort of need to find the gradient of the normal to the curve at point A. So imagine if we somehow have a weird looking curve like this. There's some point right there. We know what the coordinates are. All we need to do is we need to find the gradient at that point. That's why we have the derivative. The derivative is what the gradient is. So we got dy by dx being equal to 4 times 2x minus 5 raised to the power 3 minus 9x raised to the power 1 by 2. And we already know the x coordinate of point A, which is 4. So let's chuck that 4 in here, and then we will find the derivative at point A. So that's just going to be dy by dx is equal to 2 times 4 minus 5 raised to the power 3 minus 9, 4 raised to the power 1 by 2. Let's simplify this a bit, and this is just going to be 2 times 4 is 8. 8 minus 5 is going to be 3. 3 cubed minus, this power means under root, so it's going to be 9 under root 4. Under root 4 is 2. 2 times 9 is 18. And we can solve all of this out in our calculator. 4 times 3 raised to the power 3 minus, minus 18 and that is going to give us 90. So the derivative is going to be 90 at point A. In part B, we're supposed to find the equation of a curve. How do we do that? Well, when you have the derivative equation for a curve, you can integrate that. Integrate reverses the differentiation, and it gives you the original equation for the curve, right? So what we're going to do is we are going to have our dy by dx equals 4 times 2x minus 5 raised to the power 3 minus 9 x raised to the power 1 by 2. And see, now we need to integrate both sides. So when we integrate this side, we're going to get y. Simple as that. And then we integrate all of this. 4 times 2x minus 5 raised to the power 3 minus 9x raised to the power 1 by 2 dx. Now, you can go ahead and solve this differential however you would solve it. Just check if there's, okay, so there's no space over there, so we have to make it work in this space right here. Now, you can integrate however you've learned integration. I'm just going to do it how I've learned it. So what's going to happen is I can basically separate out these two integrals. So I'll have 2x minus 5 raised to the power 3 dx minus integral 9 x raised to the power 1 by 2 dx. Okay, this is pretty straightforward. This is just going to be 1 by 2 is what? 1 by 2 is 0.5. So this is simply just going to be 9 times x raised to the power 1.5 divided by 1.5. And then this guy right over here, we can use some u sub over here. And the way it works is basically you say all of this is basically u. So you say u is equal to 2x minus 5. And then you find out what you differentiate u. So du by dx is going to be 2. And then you make dx the subject. So that is just going to be 1 by 2 du. And what you can sort of do then is you can erase all of this. Instead of having all of this, you can say it's u raised to the power cubed. So it's u cubed. And then instead of having dx, you already know what dx is in terms of du. So that is just 1 by 2 du. Now, all of this stuff is multiplying, and this 1 by 2 is a constant, so you can take it out of the integral. When you do that, it's going to be 4 divided by 2. That is going to simplify and just straight up give you 2. Oh, my bad, this was a power of 3. And now it's really simple. All you got to do is this is going to be 2. U raised to the power 3 is going to integrate to u raised to the power 4 over 4. Okay, and you know what u was. U was initially 2x minus 5, so it's going to be 2x minus 5 raised to the power 4. And now what you can do is you can say 2 times 1 is 2, 2 times 2 is 4. So all of this is going to simplify and give you this thing. Bam. And then all of this thing is just going to give you 9 divided by 1.5. So you're going to get minus 6x raised to the power 1.5. This is the equation for y. Don't forget your plus c at the end. Now you have to find what that plus c is. That's why they gave you that coordinate a, 4 and negative 11 by 2. So you know what y is, you know what x is. Make c the subject, find out the value for c. Y is negative 11 by 2. And then what is x? X is 4. So this is going to be 2 times 4 minus 5 raised to the power 4 divided by 2 minus 6 raised to the power 4 6 multiplied by 4 raised to the power 1.5 plus c. And then we can sort of do all of this out on our calculator. This is going to be 2 times 4 is 8 minus 5 is going to be 3 raised to the power 4 divided by 2 minus 6 times 4 raised to the power 1.5. This is going to be negative 15 by 2. You send this to the other side, it's going to become a positive number. Okay, and then you will subtract from it 11 by 2. So c is simply just going to be 2. So that means your equation is going to be all of this plus 2. This is your final answer. Before heading to part 3, I just realized that I made a mistake in part A. And what the mistake was that I was supposed to find the gradient of the normal. What I did was, let's say if this right here was the point A, so this is point A, what I just did is I just found the gradient of the curve at this point, or the gradient of the tangent line at this point. So let me just draw a different curve. Imagine if the curve was something like this, and this was point A. What I've essentially done is I found out the gradient of this tangent line. They don't want the gradient of the tangent line. They want the gradient of the normal line. So a normal line will basically be like this, going straight through this point, and a line that's 90 degrees to the tangent. Okay, so it's 90 degrees to the tangent. So the gradient of this line is basically going to be the negative reciprocal of this tangent line's gradient, which we already found out to be 90. So then this is, the gradient of this line is just the negative reciprocal of 90. So we can sort of negative this. This is just going to become negative 90, and then we can reciprocal this. It's going to be 1 over negative 90, which is just going to be negative 1 by 90. Now this would then be the final answer. Okay, so moving on to part 3, and it says the third term of a geometric progression is 18, and the sum of the first 3 terms is 26. It is given that the common ratio is negative. So we know that r is negative. R is negative. What we need to do is we need to find the 10th term of the progression, giving our answers to 3 significant figures. So the way to do that is by basically using the formula S, sum of a geometric sequence is equal to a multiplied by 1 minus r to the power n divided by 1 minus r to the power n. Now, see this, we know what this n is going to be. It's going to be 10. The problem is we don't know this a, the first term. We don't know this r either. So what we first have to do is we sort of have to use the information we are given in the question to first find out what a and r are going to be. And the way we do that is, well, so we need to find a as well as r. So it's most probably going to have something to do with a simultaneous equation where where we're going to make two equations for two unknowns and then solve them simultaneously. That's how they want to test you on these sort of questions. So reading the question, it says the third term of a geometric progression is 18. So that means that a raised to the power r, n minus 1, and n could be, so nth term. Basically what I'm trying to say is the nth term of a geometric progression is given to us as a multiplied by r raised to the power n minus 1. Now for the third term, our n is just going to be 3. And we know what that third term is, right? It's 18. We can chuck in an 18 in here. So it's going to be 18 is equal to ar cubed, ar squared. And then we're also given that the sum of the first three terms is 26. So you can see we have one equation, but the problem is, as of now, we have two unknowns, a and r. We cannot solve one equation with two unknowns. What we can do is we can solve two equations and two unknowns, and that's where the second bit of information comes in. So they say the sum of the first three terms is going to be 26, so that means 26 is going to be the sum of a plus a raised to the power r plus a raised to the power r squared. And we already know what this guy is going to be, because a multiplied by r raised to the power 2, we already know that's going to be 18. So 26 is equal to a plus a times r plus 18. Now what we have over here is two equations, two unknowns. This is the first one, this is the second one, and as I said, we will be solving this simultaneously. The first thing we can do is we can make a or r the subject, and we can sort of solve this equation out. And what we can do is we can make a the subject. Yeah, let's do that. You can make r the subject if you want to. I'm just going to make a the subject. So we take equation 1. You can take equation 2, whichever one you'd like. Doesn't really matter. Actually, you know what? I'll take equation 2. So this is 26 equals, actually, I'll take equation 1. I'm sorry for being indecisive. So it's going to be 18 over r squared is equal to a. Okay? And then we can chuck this guy into the second equation. So that's going to be 26 equals a, which is going to be 18 over r squared, plus 18 over r squared times r, and then plus 18. So this r is going to cancel out with this r, and we are going to be left with 26 equals 18 over r squared plus 18 over r. And what we can do is we can send this guy to the other side. This was plus 18, right? We can send this to the other side. It's going to subtract, and we are going to be left with 26 minus 18. We're going to be left with 8 is equal to 18 over r squared plus 18 over r. And now what we can sort of do is we can take LCM, add these guys up. We can take our LCM, add these guys up. We're going to have 8 is equal to 18 over r squared plus 18 times r. Okay, I get this thing. And then what I can sort of do is I can send this thing over there to multiply, and I'll get 8r squared equals 18 plus 18r. Rearrange everything. 18r squared minus 18r minus 18 equals 0. It's a quadratic equation. Now I can solve this out. I'm going to use my quadratic formula, which is going to be minus b. So minus times minus 18 is going to be plus 18. And then square root minus 18 squared minus 4 times 8 times minus 18 divided by 2 times 8 is 16. So this is going to be 3. And then we can get our other answer by changing the sign to negative. Change the sign to negative, and we get negative 3 by 4. Negative 3 by 4. This is the thing we're going to reject. Why? Because r is not supposed to be positive. They told us right at the start, that r is going to be negative. So we're going to go with this value. And now we have this. We can go ahead and find a. So we can get the equation of a, which was 18 divided by r squared. So then a is just simply going to be 18 divided by negative 3 by 4 squared. So that is just 32. Now we have a, we have r. Now what we can sort of do is we can find the 10th term, the term we were trying to find. So S10 is equal to 32 bracket 1 minus minus 3 by 4 raised to the power 10 over 1 minus minus 3 by 4 raised to the power 10. So let's sort of solve all of this out. We got 32 times 1 minus minus 3 divided by 4 raised to the power 10. Close the bracket, and then do the same in the denominator. 1 minus minus 3 divided by 4 raised to the power 10, and close the bracket again. All of this is going to just be 32. So S, sum of the first 10 terms, is going to equal 32. That is our answer. Now we go on to part B, and it says find the exact value Wait, did we do this right? I think we did something wrong here. Because we were supposed to give our answers correct to 3 significant figures. I guess then we can just write 32.0. I guess that would make it 3 significant. Would it? I don't think so. Wait, actually, I realized I was supposed to find the 10th term, not some of the first 10 terms. And so what I can sort of do is I can just say, okay, my 10th term is going to be, so scratch all of this. My 10th term is going to be a r n minus 1, so 10 minus 1 is going to be 9. This is just going to be 32 times minus 3 by 4 raised to the power 9. And so this is going to be, a is what? 32 times minus 3 divided by 4 raised to the power 9. That is going to be negative 2.40, negative 2.40. Okay, so going to part B, what we sort of have to do is we have to find the exact value of sum to infinity of the progression. So the formula for that is basically a over 1 minus r. We know what r is, so this is going to be 32, 1 minus 3 by 4, and this has a minus sign as well. So 1 minus 3 divided by 4 is just going to be 7 by 4, so this is 32 divided by 7 by 4, and I can write it as 32 divided by 7 by 4. Now we can change it into multiplied by 4 by 7, and so this is going to be 32 times 4, that is 128, and I don't think that this is divisible by 7. So it's not. So this is just going to be the answer in its exact form. We're on to question 4, and we have a diagram over here, and the question says the diagram shows a curve with the equation y equals 5x raised to the power 3 by 2 minus 20x, and the line with the equation y equals x minus 16. The x coordinates of the point of intersection of the line and the curve are 1 and 16. Find the area of the shaded region between the curve and the line, okay, which is this area right here, which we're supposed to find, this guy. And so how we could do this is we can basically, this would be the first point of intersection, this would be the second point of intersection. So this guy is going to be x equals 16. This guy is going to be x equals 1. And then what we can sort of do is if we integrate this guy for this area, we're basically going to get this thing. We're going to get all of, I draw a line over here just to show you guys. We are going to get all of this area right here. And this is going to be in negative. Why is it going to be negative? Because the curve and the line are both under the x-axis. So this is going to be a negative area, and what we are going to do is we are going to take the modulus of it, or the positive value of it. Okay? So all of this is going to be a negative area, and we are just going to modulus it. If you don't know what modulus is, it doesn't even matter. Basically, it's going to be a negative value. When we solve it out, we're going to get a negative value. We're going to remove that negative sign. When we solve this, we're going to get a negative value for the area. What we are going to do is we're going to remove that negative sign, because that negative sign means nothing but saying that the area we are finding is under the x-axis, not above the x-axis. So we're just going to convert this into a positive sign. Okay? That's all it means. And then what we sort of do is we have to find the area of the line as well. So that is going to be this area, which is also under the x-axis. So this is going to be negative as well, and we're going to find it, and we're going to convert it into positive. Now, it's not going to be a negative area. If you find it using geometry, then it's not going to be negative. If you do use integration to find it, then it is going to be negative, and you will have to manually convert it into positive. And then once we do all of that, what we're supposed to be doing is we're just going to subtract from the red area the green one, and we will basically get the shaded part. Okay, so how do we find the area under the line? So the area under the line, we can see it's making a triangle. It's looking like sort of something like this. Okay, and this is, at this point, x was 1. At that point, x is 16. So in between them, the interval, or the distance, or the side, is basically equal to a length of 15. From 1 to 16, you have 15 units in between them. And then this point right over here, this guy, this x equals 1, we can find out the y coordinate at this point using the equation of the line. Because, see, the line is passing through this point. We know the x coordinate of that point. We can chuck it into the equation, find the y coordinate. That's what I'm going to do. So I got y equals, x is 1 minus 16. And so y is going to be equal to, 1 minus 16 is going to be minus 15. So this is minus 15, but I'm not going to take that minus sign into consideration, because that minus sign just means we're going down. That's no concern. It's of no concern to me because I'm finding the area. So I don't really need the negative sign. And so now I have this triangle over here with one side of 15, the other side is 15. How I do it now is I find its area is going to be 1 by 2 times base times height. Base is 15, height is 15, so I can just say 15 squared. And so this is going to be equal to 0.5 times 15 squared. So this is going to be 225 divided by 2. 225 divided by 2. Now this is actually that green area that you were looking for. We found that one. What we need now is that red area. And the way we do that is, well, we can integrate it. So we can say integral from, because we are now finding the area under the curve. that is going to be integral from 1, x equals 1 to x equals 16 of this curve, which is 5x raised to the power 3 by 2 minus 20x dx. And so now you can integrate it in whatever way you've learned it. I'm going to integrate how I've learned it. So this is just going to be 5 times, so 3 by 2 is, I believe, 1.5. So I add into it 1, and I just get x raised to the power 2.5 divided by 2.5. And then I get minus 20 x raised to the power 2 divided by 2. And the limits are 16 and 1. We can simplify this a little. 2 times 1 is 2. 2 times 10 is 20. And 5 divided by 2.5 is going to be 2. So this thing 1, this thing 2. Now we get 2x raised to the power 2.5 minus 10x squared. Limits are 16 and 1. We can apply these limits, and we are going to get 2 times 16 raised to the power 2.5 minus 10 times 16 raised to the power 2 minus 2 times 1 raised to the power 2.5 minus 10 times 1 raised to the power 2. And this 1 can be raised to any power. It doesn't matter. It's just going to be 1. So all of this is just going to simplify to, all of this is going to simplify to 2 minus 10. So what is 2 minus 10? 2 minus 10 is minus 8. And over here, all of this is going to simplify to 2 times 16 raised to the power 2.5 minus 10 times 16 raised to the power 2. Solve it, and we get negative 512. Okay, and we can solve all of this. Negative 512. This negative and this negative are going to make this 8 positive. So plus 8. And we get minus 504. Minus 504. Now I told you you're going to get a negative answer for the area because your area is under the x-axis. So you're just going to turn this into a positive number, 504. And then this is your red area that you were looking at. So now you can minus the red area, sorry, minus the green area from the red area. It's going to be 504 minus 225 over 2. Let me see if that was 225 over 2. Yes. So this is going to be 5 by 4, 504 minus 225 by 2. That is equal to 391.5. 391.5 units squared. Now we're on question 5, and we need to find the first 3 terms in ascending powers of x in the expansion of each of the following expressions. So if we need to expand these guys, we need to use binomial theorem. And what we are going to do is we need to expand this guy to the first 3 terms, and then this guy to the first 3 terms. This is going to be 5 choose 0 times a, which is 2, raised to the power 5 minus 0, which is going to be 5, times minus px raised to the power 0. And then the second term is going to be 5c1, 2 raised to the power 5 minus 1, which is going to be 4, times minus px raised to the power 1. And then we got 5c2 times 2 raised to the power 5 minus 2, which is 3, minus px raised to the power 2. So what do we got? 5, what is 5c0? 5c0 is going to be 1. So this thing is 1. This thing is raised to the power 0. That's going to be 1. So we're just going to have 2 raised to the power 5, which is 32. And then we got 5c1 times 2 raised to the power 4, which is 80. So that 80 is going to multiply with this negative sign. It's going to become negative 80px. And then we got 5, so we got 5c2 times 2 raised to the power 3, which is going to be 80. And then this thing squared is going to be positive p squared x squared. So we're going to have positive 80 p squared x squared. Okay, let me just check if this is correct. 5c2. Okay, perfect. Now we go over to our second expansion. And so this is going to be, again, 4c0 times 1 raised to the power 4 times minus x by 2 raised to the power 0 plus 4c1, 1 raised to the power 3, and then minus x by 2 raised to the power 1. And then we got 4c2 times 1 raised to the power 2 times negative x by 2 raised to the power 2. So for the first term, we are going to get 1 from this guy, 1 from this guy. 1 raised to the power 4 is just 1. In the next part, we got 4c1. That is going to be 4. Okay, this entire thing is going to be 1. So we can count this out. And this raised to the power 1 is it's just going to be itself. This is going to be 4. And so 2 times 1 is 2. 2 times 2 is 4. We are going to get negative 2x. I hope I didn't do anything wrong over there. Yeah, I think I didn't. And then we got 4c2, which is 6. And this thing is going to be 1. This thing is going to be 6. We square this thing is going to become a positive number, which is going to be x squared over 2 times 2 is 4. So we can sort of simplify this as well. 2 times 2 is 4. 2 times 3 is 6. And so these things are being multiplied. So we're just going to have 3 over 2x squared. So these have been expanded to the 3 terms as well. And we can now head on to part B. Part B says, given that the coefficient of x raised to the power 2 in the expansion of this thing multiplied with this thing is 93, find the possible values of the constant p. So what is the question even asking you? Well, it's asking you if you expand this thing, this bracket multiplied by this bracket, in such a way that you get a coefficient of x squared, then what's going to happen is the coefficient is going to equal to this 93. And what do they even mean by that? So look, you have to find out how this bracket and this bracket can be expanded in such a way that you get a term that has only x squares inside of them, because that's what you have to expand it to. That's what the question told you, that you need to get a term which is going to have x squared, and then you need to deal with the coefficient of that term. So what that means is that if you basically go to these two parts, the reason they made you do all of this is it's going to make sense in just a bit. You have from expanding the first bracket, you have 32 minus 80px plus 80p squared x squared, and then from expanding the second bracket, you have 1 minus 2x plus 3 by 2 x squared. Now see, thing is, you have to multiply these things in such a way that you get the expression you get will only have x squares inside of them, nothing other than x squares. And how do you do that? Well, you basically multiply the first term, which does not have an x, with the last term, which already has an x squared. So these two things are going to multiply, give you something that only has an x squared. And then you got this term, which has an x, and you multiply it with a constant. Sorry, not with a constant. You multiply it with this guy, with the central guy. Why? Because these two things have an x. So when you multiply them together, it's going to become x squared. And then this thing already has an x squared, so you're going to multiply it with this constant term 1, so you get a term that has an x squared. Now, you don't want to multiply this thing with this thing. The reason being that they both have x squares. And so if you multiply them, you're going to get x to the power 4. That is not what we want. The question clearly asked you for x to the power 2. So don't do this. And instead, what we are going to get is 32 times 3 by 2 x squared. And then we are going to get plus 1 times or negative 2x times negative 80px. Instead, I'm just going to represent this multiplication sign with a dot, because otherwise it's going to be a little confusing. And then plus 1 times 80p squared x squared. Okay, so what's going to happen is that this term is going to be 2 times 1 is 2, and 32 divided by 2, let's see, 32 divided by 2, that is 16. We're going to get 16 times 3. 16 times 3 is 48 x squared, and negative 2 times negative 80 is going to be negative 2 times negative 80. That's going to be positive 160 p x squared, and then we are going to have plus 80p squared x squared. And see, now what you're trying to do is you have x squared in all of these terms. So what you can do is you can write 48 plus 160p plus 80p squared. Take the x squared out as common, and now you see what you have is all of this is a coefficient. It's being multiplied to this x squared, and this is your x squared term. And what they say is that this coefficient, all of this, what this is equal to is, if you go up to the first part, it says that all of this is equal to 93. So in fact, what I can do is I can just make some space over here, make some room for working. What we sort of have over here is we have 80p squared plus 160p plus 48, and all of this, the coefficient, which is this entire expression, all of this has to be equal to 93. So what we can do is we can bring the 93 to the other side. It's going to be 48 minus 93. It's going to be negative 45. So we got 80p squared positive 160p, and I think it's negative 45. Negative 45 equals 0. You can see we sort of now have a quadratic, and to solve this quadratic, we can use the quadratic formula, which is going to be negative b. So it's going to be negative 160 plus under root 160 squared minus 4 times 80 times c, which is negative 45, divided by 2a, so 2 times 80. Now all of this is going to be 1 by 4, so p is equal to 1 by 4, and then the other possible value for p that you can have is going to be 9 by 4. So, or p is equal to negative 9 by 4. And that is it for question 5. Now we're on to question 6, and question 6 says the equation of a curve is something, and the equation of a line is something, where k and p are constants. Given that k is equal to 2, p is equal to 11, find the coordinates of points of intersection of the curve and the line. So if you have the equation of a curve, you've got an equation of a line, you need to find where they intersect. You need to solve them simultaneously, and you will find that. And we have these two constants, k in the equation of a curve and p in the equation of a line, and they say k is equal to 2, p is equal to 11. Okay, so we got 2x squared minus kxy. K is 2, so minus 2xy plus 2 equals 0. And then we got y is equal to px, so p is 11, so 11x plus 3. And what we need to do is we need to find the points of intersection. So what we can do is we know this is the equation of a line. We can put this in this equation. So we will get 2x squared minus 2x. And instead of y, we can put 11x plus 3 plus 2 is equal to 0. Start solving it out. So this is going to be 2x squared minus 22x squared minus 2 times 3 is 6, so that's going to become 6x, and plus 2 is equal to 0. Now all of this is going to be negative 20x squared minus 6x plus 2 equals 0. I don't want this negative sign to be here, so what I can do is I can multiply the entire equation by negative 1, and I'll get 20x squared positive 6x negative 2 is equal to 0. And now what I can do is I basically have a quadratic. I can solve this using the quadratic formula. So minus b is going to be minus 6 plus under root 6 squared minus 4ac over 2a. So 2a is going to be 40. So one of the values is 1 by 5, and the other value is going to be, we put the sign to negative, we put this sign to a negative, and it's going to be negative 1 by 2. And now what we can do is we have our 2 points, 2 x coordinates where the line intersects the curve. We can find the corresponding y values for these. So we can use the equation of the line or the equation of a curve, doesn't matter. I'm going to use the equation of the line because it's much simpler. So y is equal to 11, and instead of x, I'm going to put 1 by 5 plus 3. And over here, I'm going to have y equals 11 multiplied by minus 1 by 2 plus 3. So let's solve this out. 11 times 1 by 5 plus 3. That's going to be 26 by 5. So one of the points of intersection is going to be 1 by 5, comma 26 by 5. And then the other point of intersection would just be minus 11 by 2 plus 3. So negative 5 by 2. So this other point is going to be negative 1 by 2, comma negative 5 by 2. These are the 2 points of intersections for the line and the curve. Now part B says, given instead that p is equal to 4, find the set of values of k for which the curve and line do not intersect. So they give us p, and they say you have to find k. Okay, how do we solve this? So again, we know if we want to find values or coordinates for a curve and a line, what we do is we basically merge their equations, or in other words, solve them simultaneously. So again, the first step is going to be having our curve equation and our line equation, which I forgot. It's okay, so it's 2x squared minus kxy, 2x squared minus kxy, and it's plus 2 equals 0. Plus 2 equals 0. Okay, and then the equation of the line is going to be y equals 4x plus 3. So y equals 4x plus 3. Again, what we need to do is we need to merge these equations together. So this is going to be 2x squared minus kx, and y is going to be 4x plus 3 plus 2 is equal to 0. So we can sort of do a little bit of expansion over here. This is 2x squared. It's going to be minus 4. Actually, I don't want to multiply the k right now, but I think I should. Okay, you know what? I'll just do it anyway. So 4kx squared, right? And then plus 3kx plus 2 is equal to 0. Perfect. Now we can sort of do something, and that is to take this x squared out as common. And so we are going to have 2 minus 4k x squared plus 3kx plus 2 is equal to 0. Right. At this stage, I want you guys to realize one thing, why I took x squared out common in this part. Because once I do that, my equation basically now looks like ax squared plus bx plus c. I want you guys to see what all of these terms are. All of this is a, all of this is b, and this guy is c. And see, what they told us in the question was that we need to find a set of values for k such that the curve and line do not intersect. So this is the merged equation, right? You merge the line equation, curve equation, boom, you get this equation. Now you want the line and curve to not intersect. So that means that in order for us to set that condition, the discriminant of this merged equation, the discriminant is b squared minus 4ac, that thing has to be negative. In other words, that means it has to be less than 0. And when you set this condition basically means that your line and your curve will not intersect. And you have to set this condition for this merged equation right over here. Now, if you don't understand why this is the case, why we're doing this, why all of this happens, there's a video called Quadratics on my channel, and you guys should check that out. Okay, so what we need to do is we need to say b squared minus 4ac is less than 0. What is b squared? B squared is 3k. So it's going to be 3k squared minus 4. A is 2 minus 4k. And then what's c? C is just 2. All of this has to be less than 0. So 3k squared is going to be 9k whole squared minus 4 times 2 is 8. And negative 4 times negative 4k is going to be positive 16k. And then, wait, I sort of messed this up. What I can do is I can multiply this 2 right over here with this 4, and right off the bat I'll get negative 8 to start off with here. And then negative 8 times 2 is negative 16. Negative 8 times negative 4, I think that's negative 32. So that's going to be positive 32k. All of this has to be less than 0. So this is 9k squared plus 32k minus 16 is less than 0. Okay, now what we need to do is we can solve the quadratic part of this, or if you don't want to do that, again, how to solve this, I've given that in my quadratics video, but if you haven't watched that, then there's not much I can do about that. So one thing I'm going to do is I'm just going to solve this equation I have, this guy right over here, and this time, actually I'm going to use the quadratic formula as usual. So this is going to be minus b, so minus 32 plus under root b squared, 32 squared minus 4 times a, which is 9, times c, which is negative 16, divided by 2 times a, so 2 times 9. And one of the points we get is going to be k is equal to 4 by 9. And then the other points we get is going to be, if we change this to a negative, we can get that point. We got to change this to a negative. We get negative 4. We get 4 by 9 and negative 4. So what I want you guys to do is draw a number line over here. Put negative 4, put 4 by 9, and what is 4 by 9 in decimals? So that is going to be 0.444, right? So that's just 4.9. Okay. What I want you guys to do right now is check this section, this section, this section, and basically put it in that equation up there, this entire equation, and see which values work, which values do not work. So let me just do that for you guys. You got 4, right? So you can use anything smaller than 4 in this region right over here. You can use anything. I am going to use a number smaller than 4. I'm going to use, let's say, negative 5. Okay? And so what I'm going to have is, okay, so negative, so 9. So I plug this negative 5 up there into that part. So 9 times negative 5 squared plus 32 times negative 5 minus 16. So we get 49. Now 49, is it less than 0? Big no, it's not less than 0. So that means this section is out. Now we check this middle section. So from negative 4 to 4 by 9, what we are going to do is we are going to say, we're going to pick a value between negative 4 and 4 by 9. So the simplest value is 0. So if you put 0 and you put that into this equation, 9k squared is going to be 9 times 0 squared. That's going to be 0. Plus 32 times k. K is 0 because we chose that value. So it's going to be 0. And we're going to be left with negative 16. So is negative 16 less than 0? Clearly it is. So this section has checked out. The section between negative 4 and positive 4 by 9 has checked out. For the last section, what we are going to do is we can pick another value. So if this is 0.444, we can pick 1 from this side. And then what we have is we have 9 times 1 squared. So anything, so I don't even have to write 1 because this is just going to be 9, right? But anyways, I'll write it anyway. 1 over here and then negative 16. So this is 25. Is 25 less than 0? It's clearly not less than 0. So this value doesn't check out either. So for these values of k, so if k is greater than negative 4 and k is smaller than 4 by 9, so between this range, any value of k that you choose, your line will not intersect your curve. So we're on question 7 now, and it says the equation of a curve is something something, and that a point P is moving along a curve in such a way that its y-coordinate is decreasing at 5 units per second. So what that means is, let's say I imagine a curve over here that looks something like this. And on that curve, I have a point P. Now, after 1 second, the point P is going to be over here, and the y value that changed between these 2 points was basically of 5, and it decreased. So it's going to be negative 5. Okay, so that's what all of this means. So what this rate means, that it's changing at 5 units per second, it means that the y quantity is changing with respect to time, and it's changing with negative 5 units per second. Negative means it's decreasing at negative 5 units per second. And then what we have to find is the rate at which the x-coordinate of point P is changing when x equals 2. So see, we need to find the rate at which the x-coordinate is changing. That means we have to find dx by dt at the specific instant when x is equal to 2. So again, point is, if you look at this diagram I drew up over here, of course, when the point P is going from its first initial position to its final position, of course, it has some change in y, but it's also going to have some change in the x direction, right? So what we need to do is we need to find that change. We need to find that dx by dt. So how we do that is basically, this is a related rate problem, and you have 3 quantities. You have to find how x changes with respect to time, right? You have to find how x changes with respect to time, or dx by dt. But the thing is, you are given an intermediate quantity, right? You need to find the relation between these 2 quantities, but you have a third quantity, which is y. So if you have to find dx by dt, you first need to find this guy, which is dx by dy, and then multiply it with this guy. Multiply it with this guy, which is dy by dt. So essentially, dx by dt is going to be dx by dy times dy by dt. dy by dt. Okay, so do we know what dy by dt is? Yes, we do. It's negative 5. So we can put that negative 5 over here. do we know what dx by dy is? We do not know that. And see, how we can find that is basically they gave you the equation of the curve, so this guy right over here. And so what you can do is you can differentiate this equation of the curve, find the dy by dx, and then just sort of realize that dy by dx will just be the reciprocal value of dx by dy. So once we use that curve to find dy by dx, we can reciprocal that value, and we will get dx by dy. So what we will do is we will basically write that equation, y equals 4x squared plus 9 times x raised to the power negative 2 minus 8. And so you can find your dy by dx, which is going to be 8x minus 18 x to the power negative 3, and that minus 8 is just going to be 0. So let me just check that. This is 8, this is 18x raised to the power negative 3. And remember, they want the rate, they want the dx by dt at a certain specific instant. And that instant is when x is equal to 2. So we can set that condition right now. What we are going to do is we have this dy by dx, right? What we are going to do is we are going to put that 2 in here. We are going to solve it out, and then we will get a value for dy by dx. But we don't need dy by dx, do we? We need dx by dy. So then the value we get, we are simply going to reciprocal it. So this is just going to be dy by dx at this condition 2. It's going to be 8 times 2, negative 18 times 2 raised to the power negative 3. So this is going to be 8 times 2, negative 18 times 2 raised to the power negative 3. And this is 55 over 4. So dy by dx is 55 over 4. Now remember, we do not want dy by dx, we want dx by dy. So dx by dy is just going to be the reciprocal of this, and so we'll get 4 over 55. So now we sort of have this 4 over 55. We know what dx by dy is, we know what dy by dt is, therefore we can go ahead and find dx by dt. So dx by dt is just going to be 4 over 55 times negative 5. So 4 over 55 times negative 5. Sorry, that's negative 2, negative 5. That's going to be negative 4 by 11, negative 4 by 11. That is your rate of change of the x coordinate. Now we're on to part B, and it says find the coordinates of the stationary points of the curve and determine their nature. So we already know what dy by dx is because we found it out in the last part. So dy by dx was equal to 8, I believe it was 8x minus 8x minus 18x raised to the power negative 3. And then we have this, we need to find the nature as well. So we need to find the double derivative, d squared y over dx squared. So this is going to be, we can differentiate the derivative. It's going to be 8 minus, this is going to be plus 54x to the power negative 4. Okay. Is that correct? Yes, I think that is correct. Right, so what we can do now is we can put this guy equal to 0, the differentiation equal to 0, because we're trying to find the stationary point. This is going to be 0 equals 8x minus 18x to the power negative 3, or I can write it a bit differently. I can write it as such, x to the power 3. Okay, and then what I can sort of do is I can multiply both sides of the equation by x to the power 3, and so what that is going to do is this thing is going to become 8x to the power 4, and this thing is just going to become 18. So what I did over here is I multiplied both sides of the equation with x to the power 3. Okay, now I can send that 18 to the other side, so it's going to be 8x to the power 4 equals 18. And what I can sort of do is I can take the 8 over there to the other side, so it's going to be 18 over 8, and this is going to simplify to give me 9 by 4. Okay, and one thing I can do now is, well, I can simplify this a little bit. I can basically take the square root on both sides of the equation, and what that's going to do is it's going to simplify this 4 out for me. So it's going to simplify this 4 out for me, and so I'm going to be left with x squared equals under root 9 is 3, and under root 4 is 2. And then I can send this square to the other side, so I'll get plus minus 3 by 2. Right. Now, what I need to do is I need to check the nature of these stationary points. So I have this thing, 8 squared y over dx squared, 8 plus 54 over, x to the power 4. And both of these answers are going to be minimalist. The reason for that is because one of the x is a positive value, right? Positive under root 3 by 2. The other is negative under root 3 by 2. But see, this 4 is an even power. So if I put the positive number in here, it's just going to be all of this fraction 54 by x raised to the power 4. All of this is going to be a positive number if I put a positive number in place of x. When I put a negative number in place of x, the even power 4 is going to convert it into a positive number, and the fraction is still going to be a positive number. So either way, I get a positive number. Either way, my double derivative is going to be a positive number. And positive number basically means I have a minima. So both of these things, both of these guys are minimas. So both are minimas. Minimas. If you don't believe me, you can go ahead, solve it out individually, put in both of these values of x, and you will get the answer. What we have to do is we have to find the coordinates, so we still need the y coordinate. So we know the equation of the curve, y equals 4x squared plus 9 over x squared minus 8. Let me just check to see if that was the original equation. Yes, okay. So what I can do is I can put both values in here. So I'm going to do it for positive under root 3 by 2. I'm going to do it for negative under root 3 by 2. So I get 4 times under root 3 by 2 raised to the power 2, and I get plus 9 divided by, and I can sort of write it as 9 divided by under root 3 divided by 2 raised to the power, raised to the power 2, and then I can have negative 8 over here. So that is going to be 4, so I get 4 from over here. And then I'm going to get 4 from over here as well, because why? Because see, that power, that's an even power, it's power of 2, this is an even power. And all of this entire thing is the same as this thing, the only difference is the sign. The sign is negative over here. When I raise this to the power 2, that sign is going to become positive. And so I'm going to get the same answer as when I use this guy. So one of them is going to be, one coordinate is going to be 3 by 4. It's 3 by 2. 3 by 2 comma 4, and then the other one is going to be negative 3 by 2 comma 4. Question 8 right here, boys, and this generally is an 8-mark question, so it's not going to be easy. The circle with equation x squared plus y squared, okay, I'm not going to read all of that, intersects the line x equals negative 2 at the points P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q at line x and the line x equals negative 2. Whoa, that's a lot of words. I need a diagram for this because there's no way I can understand what they're trying to say, no way I can understand what triangle they're talking about. So the first thing I'm going to do is I'm going to find out what the center of the circle is. I'm going to find out what the radius of the circle is, and then I'm going to find out what the points P and Q are so I can get myself a diagram using coordinate geometry. Okay, we got a circle equation, so let's bring this into its other form. So this is going to be x squared minus 6x plus y squared plus 10y equals 27. And now we can start factorizing it. So this is going to be x squared minus 6x, and then we divide the 6 by 2, so we'll get 3. So we basically add 3 squared, and we subtract 3 squared. Then we do the same thing with y, so we get y squared, and then we have that 10, right? We divide that 10 by 2, and we're going to get 5. We add that 5, we subtract that 5. We add the square of 5, we subtract the square of 5. If you guys have no idea what I'm doing over here, you need to go and check out my quadratics video, and check out the video on how to take a quadratic equation into its vertex form. That's essentially what I'm doing over here. So this is going to be 27. Now, sorry, this was negative 3. You send this guy and this guy to the other side. The squares that are being subtracted, you send them to the other side. We're going to have x squared minus 6x plus 3 squared plus y squared plus 10y plus 5 squared equals, so this is going to become a plus. When it goes to the other side, that is going to become a plus as well. So we can say 27 plus 5 squared plus 3 squared. That is going to be 61. So that right there is 61. Let me just check that. 27 plus 5 squared plus 3 squared. Okay, perfect. And then I'm going to make 2 brackets over here, put a square on that, put a plus sign here, put 2 brackets on here, put a square up there, get the 61. Then this x is going to get in here, that sign is going to get in here, that 3 is going to get in here. And then this y is going to get in here, that sign is going to get in here, that 5 is going to get in here. So I got x minus 3 squared plus y plus 5 squared equals 61. Now my radius, now my center is going to be, so my center is going to be positive 3, and the y value is going to be negative 5. And so this is the center, right? This is the center. And then the radius is just going to be the under root of 61. So that's going to be around, the radius is going to be somewhere around 7.8 units long. Okay, that's fair. I can sort of understand that. Now I need to find where they intersect. The line x equals negative 2, and the circle, where do they intersect? The coordinates of point P and Q. So I have the value for x, which is negative 2. I have line x to be negative 2. The way I find points of intersection is I merge 2 equations together and solve them simultaneously. So I chuck this into this equation, and I'm going to get, this is important, so I'm just going to put all of this in a box. I'm going to get x, instead of x squared, I will now have negative 2 squared plus y squared minus 6 times negative 2 plus 10y minus 27 equals 0. So let's solve this out. Negative 2 squared, hold on. Negative 2 squared, negative 6 times negative 2, negative 27. So all of this is going to be negative 11, so we got y squared plus 10y minus 11 is equal to 0. And now what we can do is we got this quadratic equation. Let's solve this out. I'm going to use the quadratic formula. So minus b is going to be minus 10, then plus under root b squared, 10 squared, minus 4ac, a is 1. I don't have to write that, c is negative 11, and then 2 times a, so a is 1, so it's just going to be 2. One of the values is going to be 1, and the other value is going to be, I can change the sign to negative, and I will find the other value. So I change the sign to negative. That's going to be negative 11. Okay, and what is going to be the x coordinate? The x coordinate is basically negative 2, is equal to -2. How do I know that? Well, because the line only has one x coordinate, a fixed x coordinate, x equals -2. So no matter point P or point Q, they're both going to have that x coordinate. So now what I want to do over here is, okay, I can sort of draw a graph and I can understand what they're trying to say. Okay, okay. I'm going to need a big graph over here. I'm realizing I'm going to draw a graph sort of like this. How many lines? This is my y-axis. These are like one line, 2 line, 3 line, 4 line, 5 line, 6 line, 7 line, 8 line. Okay, so if I draw my x-axis over here, so this is just a rough sketch, okay, because I can't understand what they're trying to say. 1, okay, 2, 3, 4, 5, 6, 7. Okay, whoa, okay, I'm going to need an even bigger graph than this. 8. And then over here I can have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, and -13. Okay, I think I did something wrong. I don't know that for sure, but so my radius, my center is at 3, +3, and -5. So +3 can be somewhere over here, right? That could be +3, and then -5 is somewhere around here. So that's my center, okay? And then my radius is what? My radius is 60 under root 61. So I'm going almost 8 digits away from the circle, but not exactly. So I'm going sort of in this direction. I'm almost going 7.8, which is going to be 3 plus under root 61. So that's almost going to be around 10.8, going around 10.8 over here somewhere. And then that's going to be around 10.8-ish, right? And then I'm going, you can sort of to the left. How much am I going to the left? So I'm going to be around -4.8. So around here, put a crossover there. This is around -4.8. And then I'm going, the radius is going to go up from the center. So I'm on -5 plus under root 61. That is going to be 2.81. Go over here, over here, over here. That's around over here, 2.81. Okay. Now this is obviously not drawn to scale, so please don't take this drawing seriously. And then this is we're going to go down, so we're going to be at 12.8 somewhere. So that's going to be right over here. Obviously, this diagram is not drawn properly, so I don't want you guys to be like, well, this looks nothing like a circle. I know it looks nothing like a circle. Just for understanding what they're trying to say. And then we have the line is x equals -2. So the line is going to go straight like this. So I believe this is going to be one of the points. This is going to be the other point. Okay. I don't know which is point P and I don't know which is point Q. So I guess I can call them whatever I want to call them. Okay, let's call this guy P. Let's call that guy Q. And now what I have to do is the area of the triangle formed by tangents to the circle at P and Q. That is really interesting because the tangent to P will sort of just sort of do this, sort of just do this, and then the tangent to Q will sort of just do this. So where do I have a triangle? The area of the triangle formed by the tangent. So I don't really see a triangle over here. That is interesting. Actually, I think since my drawing isn't to scale, if let's say this was the highest point, right? This was the lowest point of the circle. The circle would be something like this, right? I'm trying my best to draw a circle, and then line x equals -2 would be somewhere around here. And then the tangent to P would be like this if I extend it really long, and the tangent to Q would be like this if I extend it really long. And so I do see a triangle now, and this is the triangle that they want me to find out, this right over here. So I sort of can find this out. I can use some integration over here. And the idea over here, see, this is a good question, and I don't exactly know how I'm going to do this. I don't have my way about this, but I'm trying to understand the geometry over here. So I have something that looks like this, and like this. Okay, this is what I have so far. That is the point of intersection of the tangent line of P of the tangent line of Q. And this line right here is x. So this thing, the coordinate of this guy is -2, +1, and the coordinate of this guy would be -2, -11. And I don't know the coordinates of the intersection point. Maybe, just maybe, if I can find out that coordinate, I can do something useful with it. And then there's a bunch of ways I can go ahead and find out this the area of this triangle. The easiest way that's right now coming into my head would be to use trigonometry, which would be to use 1/2 times side 1 times side 2 times sine theta. For that, I need an angle. And how can I find out an angle? This is a difficult question. So I could have a line passing through this guy, and then this would be 90 degrees. This guy would become the hypotenuse. And I would need this angle. How will I find this angle? That is, yeah, I have no idea how I'm going to find that angle out. Is there another way in which I can sort of find out this area? I'm going to think about that. Okay, so I don't yet have an idea, but I think what I should do is I should at least try and go ahead and find out that third coordinate, this guy. So the way I'm going to do that is by getting the equation of this line, by getting the equation of this line, and solving them simultaneously because they're intersecting at that point. When I do that, I should basically get their point of intersection. So how am I going to find out the equation for this guy? Let's call this point T. Let's call this P. Let's call this Q. How am I going to find the equation for PT and PQ and QT? Well, one way of doing that would be to sort of realize that what you can do is if you draw that tangent over there, draw a tangent going down over here. If you draw a tangent going down over sort of here, then both these points P and Q, they lie on the circumference of the circle. So what that means, if this right here is the center and you draw this guy, then this will be the radius, and this will be the radius. And these tangent lines have to be perpendicular to the radius, right? We just know that straight out of geometry. And so if we can find the gradient of this guy, and we can find the gradient of this guy, and we can reciprocal it, then we can find the gradients of this tangent, and we have point P. To have a gradient and a point, we can use point slope form. We will have a point at Q, we can use point slope form again to find out the equation of the line. Then we can solve them simultaneously. I'll just do that, and you guys can see what I'm talking about. So this is the center. You can call that a C, right? And then what we can sort of do is we can find the gradient of the line PC. So gradient of the line PC. So M, which is the gradient of PC, is going to be PC. Okay, so that's going to be y2, which is the gradient, the y of the gradient. Sorry, the y of the center. Y of the center is essentially -5. So that's -5 minus y1, which is going to be 1. Okay, because P has coordinates of -2 and 1. And then x2 is going to be +3, and then minus x1 is going to be negative. X equals -2. Oh, I'm just realizing I didn't even draw this graph properly. Yeah, -2, the line -2 should have been somewhere over here in the negative quadrant, this place over here. But anyways, we don't really need an accurate drawing for this. So -5, -1 is going to be -6 over 3. Negative times negative is going to be positive, so -6/5. That's the gradient of line PC. And then the gradient of the line, we can just do it over here. The gradient of the line QC is going to be, again, y2 is -5, x2 is 3, and then minus y1, that's the coordinate of Q. So y1 is, I believe it was -11. I believe so, it was -11, yes. And then the x coordinate was negative, subtracted by -2. So this is just going to be -5, +11. That has to be 6, and then 6 divided by 5. So we got 6 divided by 5, right? Okay. Now what we can sort of do is we can find out the line equations. So the tangent line equation, so the tangent at P can be found using the point slope form. Y minus y1 equals mx minus x1. So the gradient, so this is the gradient for the line PC, which is this line from center to P, right? This line. But the gradient is normal to this. So the gradient will have a negative reciprocal of the gradient of the line PC, which means if the gradient we just found is -6/5, then the gradient will change to +5/6. So that we multiply that initial gradient, this one, by a negative, and then we reciprocal it. And then we got x minus x1, which is going to be, what was x1? It's -2. It's just going to become +2. +2. And then y minus y1. So for P, y1 is 1, +1. And we can do that over here for tangent at Q. This is the y minus y1 equals m x minus x1. Again, what is going to be y1? Y1 is going to be 11, because the coordinates of Q was -2, -11. So this is going to become +11. And then again, we have to take the negative reciprocal of this gradient. This is going to become -5/6. Okay, and then this is going to be x minus -2 is going to become +2. And then we can sort of simplify this. So this is going to become y equals 5/6x. And when you multiply 5/6 with 2, you get this thing. And from this thing, you have to add 1 into it, and it's going to become 8/3. So this is +8/3. And then you can do the same thing over here. So you're going to get -5/6x. Okay, and then you're going to get -5 divided by 6 times 2 minus 11. So that is going to be -38/3. Now we need to solve these two things simultaneously. We need to solve these two equations simultaneously. And I'm really running out of space over here. So we can say that y is equal to y. So 5x over 6 plus 8/3 is equal to -5x over 6 -38/3. And we can get the x terms on one side. So 5 divided by x plus 5 divided by x is just going to be 5/3x, 5/3x. And then we can send all the other terms to the other side. So -38 divided by 3 minus 8 divided by 3. That is going to be -46/3, -46/3. We can cross multiply over here. Or one thing we can do is we have divided by 3 on both sides, so we can cancel out these guys. And now we're just going to have 5x equals -46. So x is just going to be -46/5, -46 divided by 5. And that is equal to 9.2. So -9.2. That is where they intersect. So this is the x coordinate of that point T. This is the x coordinate of that point T. Now we still want the y coordinate, so what we can do is we can plug this value back into any equation, either this one or this one. I'm just going to plug it into one of the equations. We got 5/6 times -9.2 plus 8/3. So that is going to be, so the y is basically -5. Y is basically -5. Okay, so we got x equals -9.2, and we got y equals 5. Y equals -5. Now this, it opens up a lot of doors for us. Why? Because I just realized something. So I'm going to draw this diagram of the circle over here again. So this is the diagram of the circle. Hold on. This is the diagram of the circle. We have the circle center at this point, right? And then we have P and Q. So this is point P. This is point Q, and they're vertically above each other. Why? Because they're both, a line passes through them both, and that line is x equals -2. So they're both perfectly vertically above each other. And then what's happening is, see, there are these tangents that are meeting over here at this point. There's another tangent meeting over here at this point. And they're meeting right next to the circle. And guess how do I know that? Well, because the coordinates of the center were +3 and -5. And so the coordinates of their intersection points are -9.2 and -5. So you can see they are both on the same level, -5 and -5. So this intersection point is perfectly in line with this center point. And so the triangle they wanted was this one, right? And so what we have over here is we basically have an isosceles triangle. What does it mean to have an isosceles triangle? Well, if this is point T, this is point T, and this is point P, and this is point Q, and I saw this length has to be the same as this length. And you may ask, well, how do I know that? Again, because this line this line is passing this line is passing right through the center. So it's going to cut this this p by q in imperfect bits, in perfect pieces. Okay, now I have an isosceles triangle, and I have to sort of deal with this isosceles triangle. I can get myself just a little more space over here. So I have something like this, and I can chop it into two triangles. So if I talk about, if I just look at this triangle, I got this thing. And then see, what I can do is I can apply 1 by 2 base times height on this. Okay, or another thing that I could potentially do is basically I'm trying to think of what I could do over here. How can I? So basically, the idea is that if I rotate this, so this triangle is like this. If I rotate this triangle like this, then this is going to be t, this is going to be q, this is going to be p. And if I can find that height somehow, then I can apply 1 by 2 times base times height on this triangle, and I'll be done with this question. Okay. Only problem is that's a little tricky. Finding that height is a little tricky. Finding the base is a little tricky as well. So one thing I think I can do is if you sort of realize, if you sort of come back over here, you can sort of see that this red line was basically x equals -2. And then this point t, this is located at x equals -9/2. So I sort of can find that height. I can find that height, and the way to do that is basically to find out how much distance there is between x equals -2 and x equals -9.2. And the way to do that is I'll take my final value, which is -9.2, and subtract from it my initial value. So that is going to be -36.5. That's how much distance is between these two guys. But I don't want that negative, right? Because that negative just means I'm going left. From -2, I'm going this much to the left, and then I will end up at -9.2. But I don't want the negative when I'm finding area. So I found out this part, which I'm calling the height. This part is what? It's 36 over 5. It's 36 over 5. Okay. And then what I could find out is I still need to find my base, which is how much difference I have between q and p. And one way I could again do that is if I sort of realize that, see, q and p are on this. If I go back to my diagram right over here, I'm going back to this diagram. So p is on what is on -2 comma 1, and then q is on -2 comma -11. So what I'm trying to see is how much does it take from -11 all the way to +1. And the way to do that is I'll take my final position and subtract my initial position, which is -11, and that is going to be 12. So that means that the distance between q and p, it has to be 12. So this thing is basically 12. And now what I can do is I can say that the area of this triangle should be 1 by 2 times the base, which is 12, times the height, which is 36 over 5. And so if I solve all of this out, I should get 0.5 times 12 times 36 over 5. And that is going to be 43.2 units squared. That is my area. We are on question number 9, and question number 9 says we got a diagram of sector ABC of a circle with a center A and a radius of r centimeters. The angle BAC is alpha radians, where alpha can be between 0 to pi by 2, which is, it can be anywhere from 0 to 90 degrees. What we are told is that the area of the triangle ABC is 4 centimeters, and the area of the sector ABC is alpha centimeters. So we need to find the exact area of the shaded segment. And how do we even do that? So the area of the shaded segment is essentially this area, all of this stuff. And we can find this area if we subtract the area of the sector, so the area of the sector minus the area of the triangle. And so this thing would be the sector, right? And this thing would be the triangle. If we minus these two areas, we can get that shaded region. So what we can say is the area of the sector minus the area of the triangle. Now this would simply be 8 alpha, because we know that's the area of the sector, minus the area of the triangle, which is 4 centimeter cubed. Now the problem is we don't know what alpha is, so we need to somehow find the value of alpha. And how do we do that? Well, you don't know either alpha, you don't know alpha or the radius r. So one way you could do that is, well, you can use the equation for the area of the sector. And that equation basically says that the area of a sector is equal to 1 by 2 r squared, whatever the angle is, and the angle is alpha. So this is what we got over here, and we know the area of the sector. It's given to us as 8 alpha. Okay, so we can say 8 alpha is equal to 1 by 2, and this is going to be r squared times alpha. Now alpha is common on both sides, so we can straight up cancel that, and then we will be simply left with, we can send this 2 to the other side, so we will be left with r squared is equal to 16. And we can further simplify this by taking the square root onto the other side, and we'll get r is equal to square root 16. Now do we take the positive value or do we take the negative value? No, we take the positive value. Why? Because radius is a length. The length cannot be in negative. So this is simply just going to be 4. Radius is 4 centimeters. Now, how do we find what alpha is? And that's not hard at all. You are also given the area of the triangle, which is equal to 1 by 2 times base. Sorry, actually, we can use this other formula. 1 by 2 times side A times side B times sine and whatever the angle is between those two sides. So alpha. So we're using this side, and we're using the angle between them. Now, the area of the triangle is going to be 4, as it has been given in the question. And so you'll simply have side A and side B both are equal to the radius. So you just have radius squared over 2 sine alpha. And what you can do is you already know the value for the radius. We just found that it was 4. So you can do 4 times 4. That's going to be 16. 16 by 2 sine alpha. So what you can do is you can send this 2 over there to the other side. So you get 4 times 2 is what? It's 8. And you got h equals 16 sine alpha. And so you can now make alpha the subject, and alpha will just be, you can send the 16 over there to the other side. It's simply just going to be 8 over 16, which is going to simplify and become 1 by 2. right? So this is just going to be 1 by 2, and then you can take the sine to the other side, so it's going to be sine inverse 1 by 2. And so I believe this is equal to, let me just do that, sine inverse of 1 by 2 is 0.5, so this is pi by 6 or 1 by 6 pi. And this is correct because if you go and you check out the range of alpha, we are in that range. Pi by 6 is within this given range. So now what we need to do is we need to find the exact area of the shaded segment. This was the formula for the exact area of the shaded segment. We know what alpha is. We can just simply put alpha in here. So this is going to be 8 times pi by 6 minus 4. Let's solve this out. Pi by 6 times 8 minus 4. That is equal to 0.189. Okay, 0.189 cm squared. So we move on to part B. And part B says it is given instead that the length of the chord BC is 1 by 2 r centimeters, but the area of the triangle ABC is still 4 centimeters. Find the area of the shaded region, giving your answers correct to 3 significant figures. Okay, so now what they've done is they've said that this chord, this guy is 1 by under root 2 r centimeters. Let me check if that's what they said, and yes, that is what they said. What we have to do now is we have to find the area of the shaded region again. So now with this given information, of course, r is not going to be what it was before, so r is not going to be 4 anymore. And so this angle phi is, this angle alpha is not going to be pi by 6 anymore. We're going to have some different values this time. So let's find out what these values are going to be using what we have over here. Now you can see that this side is a radius, this side is the radius. So that means if I flip this triangle like so this is going to be A, this is going to be C, this is going to be B, this is R, this is R. What does that mean? That means that we have an isosceles triangle, which means if I draw a line straight from this top to this bottom, what's going to happen is this base CB is going to be divided into 2 equal halves. So if my base is 1 divided by under root 2, I can basically half that. And so each of these parts is going to be under root 2 over 4r and under root 2 over 4r. And now what I can do is I can use some trigonometry. So this entire angle A is equal to alpha, right? But when you break this triangle down into 2 equal parts, this angle is going to be pi by 2, and that other angle is going to be pi by 2 as well. So what I can sort of do is I can draw that one triangle out over here. This angle is pi by, it's alpha by 2. This thing is r. This thing is under root 2 by 4r. That is alpha by 2. And what I can do is I can use sine. I can use sine to find alpha. So alpha is equal to sine alpha. Sine alpha is equal to under root 2 over 4r divided by what was it? Divided by r, I believe. Yes, divided by r. This is simple trigonometry, right? And what's going to happen is I can essentially cancel out this r and this r. And actually, my bad, this isn't just alpha. This is alpha by 2. My bad, this is alpha by 2. Remember, because I split the triangle into 2 halves, so this angle that I'm finding is actually alpha by 2. Okay, so now I have sine alpha by 2 is equal to under root 2 over 4, and I send the sine to the other side. So I got sine inverse under root 2 by 4. I send this 2 over there, and now I get alpha is equal to 2 sine inverse under root 2 by 4. And so I can solve this out, find out what this angle is going to be. 2 sine inverse under root, that's cube root. I have to choose under root 2 divided by 4. What is this going to be equal to? It's going to be equal to 0.723. So alpha is 0.723 radians. Let me check if this is the value. Yes. Okay, now we have alpha. Let's go ahead and find out what r is going to be equal to. And one way we could sort of do that is, actually, do we even need r? Yeah, we probably do need r. How do we find r? That's the next big question. How do we find r? Okay, I have an idea. So they gave us the area of the triangle, right? We can use this formula and find r. So the area of a triangle is equal to 1 by 2, side A, side B, and the sine of the angle between them. So that's just going to be alpha. And what we can do is we know that side A and B are going to be these two sides, this side and this side. So they both are going to be r. And so this is going to simplify. We know the area of the triangle, it's 4. They told us that in the question. See, the area of the triangle is still 4. So it's 4 equals r squared, because A is r, B is r, they'll just be r squared, by 2 sine, and alpha is what? Alpha is simply 0.723 radians. So I send the 2 to the other side. That's going to be 8. I divide the 8 by sine 0.723. Okay. And then what I do is I have my r squared term. So I send the square root to the other side. And r is going to be under root 8 by sine 0.723. And I'm not going to take the negative value of the under root. The reason for that is because radius is a length. Length is a positive quantity. So under root 8 divided by sine 0.723. What is this equal to? This is equal to 3.48. So radius is 3.48 centimeters. Now, what I can do is, see, I wanted to find the area of the shaded segment, right? What I can do now is, again, the area of the shaded segment is the area of the sector minus the area of the triangle. The area of the triangle is still 4 centimeters. So this is still going to be 4. But what is the area of the sector? That is 1 by 2 r squared sine alpha. Okay, so it's going to be 1 by 2, 3.48 squared. times sine 0.723 minus 4. Let's solve all of this out, see what we get. So we got 0.5 times 3.448 squared sine 0.723 minus 4. We do this and we get this answer. 6.3. Did I do this right? I think I did this right. So it's going to be 6.345 times 10 raised to the power negative 3. 6.34. 6.34. Wait, I made a mistake. I'm sorry. This was not sine alpha. This is just going to be alpha. 1 by 2 r squared alpha. I'm so sorry. But this is what I made. This is where I made a mistake. I can erase this, and simply what I'm supposed to do is I'm supposed to get rid of this bracket, and I'm supposed to get rid of this bracket. And these two things are multiplying with each other. I think so. Put a bracket around that. Put a bracket around that, and this is going to be 0.378. 0.378 centimeter cubed. That is the area of the shaded segment. Okay, guys, we're on the last question, and this is the functions question. They say functions f and g are defined by f of x is equal to under root x, and the domain of x is greater than or equal to 0. Whereas function g is equal to 3 multiplied by under root x plus 2 minus 5, and the domain for this function is greater than or equal to negative 2. We need to describe fully a sequence of transformations which transforms the graph of y equals f of x to the graph of y equals g of x. So what we have to describe is how we can turn this guy into this guy. And see, it's really easy. First thing you can sort of see is you can do it in any order that you want. Okay, you can do anything that you want first. It doesn't even matter. Ideally, what I can see is there's like these two things happening over here. So see, this, first of all, we have an under root over here. If you look at g of x has 3 being multiplied to that under root. So what you can do is you can essentially multiply first, multiply function f of x. So if you have function f of x, right, this is f of x. You can multiply this with 3. Now, if you do that, what is f of x? F of x is under root x, right? So that just means you're multiplying that by 3. Then what you can see is that you have an x plus 2 inside of this. What does this mean? What does it mean when you have an x plus 2? That means that you moved to the left by 2 numbers. Okay, if there was an x minus 2 over here, that would mean that you moved to the right by 2 numbers. Plus means in functions and changing in functions, 2 means going to the left. Plus 2 means going to the left by 2 times, and the negative number means going to the right. So if you want to have instead of an x, you want to have an x plus 2, then what you need to do is you need to go to the left by 2 units. Okay, you need to go to the, hear me out again. This thing means you are going to the left by 2 units. Now, going to the left by 2 units is represented by negative 2, but when you're dealing with functions, they reverse it. The roles of positive and negatives are reversed only for functions. So what this means is that you need to go to the left side by 2. Okay, and then this negative 5, what does this mean? You also have a negative 5. So you have the 3. If you want to go to the left side, what you can do is you can put a plus 2 in here. Instead of x, now you have an x plus 2. So then instead of having an x over here, you would simply have an x plus 2 over here as well. Now, in terms of function, what does it mean when you say plus 2? It means you move to the left by two numbers. So now you got this thing. And then see, it's almost looking the same as our g of x, but there's one tiny thing left. That's the minus 5 part. So now what do you got to do? You got to move. Okay, again, another important thing. You swap the roles of plus and minus in functions only for the x value. So when I say plus 2, if I'm saying plus 2 for the x, it means I went 2 units to the left. Now, in reality, plus 2 means going 2 units to the right. But as I said, for the x values, we swap the meanings. However, for the y value, we do not swap the meaning. Negative means going down, positive means going up. So if I have a negative 5 over here, that means that my f of x has to go down by 5. My f of x has to go down by 5. So if this entire thing is my f of x, then I would just subtract 5 from this, and that would mean I'm going down by 5. Now, this thing is my f of x, right? So this is just going to be x plus 2 minus 5, and all of this is under the square root. So what is the sequence of transformations? Well, it's 1. I will say that it's first of all, I stretched it, right? I multiplied with 3, and I multiplied what by 3? I multiplied f of x by 3. So what is f of x? Well, it's y equals f of x, right? So what is this y? This y is the y quantity. It's the vertical up and down. So I say stretch by 3, stretch by a factor of 3, in the vertical direction, or you can say parallel to the y-axis. And then the second thing I did was a translation, and the translation was translation by the vector. And vector basically means direction. In which directions did you move? So I moved 2 to the left. I put a negative 2 in here, and I moved downward negative 5. Now you see, I said, realistically, in reality, you use minus when you're moving left. Okay, and since we're talking about a translation vector over here, I represented with a negative symbol. Going horizontally, going to the left means negative, going to the right means positive. Vertically, going down means negative, going up means positive. But only in this specific case of functions, when you have functions and with x you see a positive number, that means that you have to read it in a swapped manner. So if plus means going to the right, in the case of functions, it would mean going to the left. Okay, so but when you're talking about a translation vector, that's when you have to use its real meaning, not the fake meaning, not the function meaning. Okay, so I hope that makes sense. Now we go over to part B. It says the diagram shows the graph of y equals g of x. On the diagram, sketch the graph of y equals g inverse of x together with any relevant mirror line. So if this is a function and I have to draw its inverse, we know that they will be mirrors of each other in the line y equals x. So first of all, I draw the line y equals x, which is going to be a straight line like so, passing right through the origin. This is line y equals x. And then I draw the reflection of this line on the other side of that mirror. So that line is simply, just approximately, it's going to be like this. Like that's how it's somewhat going to be. Like it's a sketch, so it doesn't have to be perfect. Now we need to find an expression for g inverse of x. So what is g of x? G of x was it was 3 under root x plus 2 minus 5. Now what we need to do is we need to say that the g of x, this thing is going to become a y, and this thing is going to stay an x. Now what I need to do is I need to make x the subject of this equation. So I send this 5 over there to the other side. Okay, so it's going to be y plus 5, and I send this 3 over there to the other side. So it's going to be y plus 5 divided by 3 equals, I got under root x plus 2. Now I want to finish the under root, I send it over there, it becomes a square. So it's going to be y plus 5 over 3 square, and now I got x minus 2. Oh, my bad, it was x plus 2. And so now I can send the 2 over there to the other side. So I got x equals y plus 5 over 3 raised to the power 2 minus 2. I believe that is correct. And now what's going to happen is that x is going to change into y, that y is going to change into an x. Okay, this is what I have now. And now this y is basically going to be g inverse of x is equal to x plus 5 over 3 squared minus 2. Now state the range of g inverse. So what is going to be the range of g inverse? It's going to be whatever the domain was, for g of x. And that was x is greater than or equal to negative 2. So x is greater than or equal to negative 2. We got the function h is defined by x minus 2, and then we have a range over here. Yes, sorry, a domain over here for x, and x has to be greater than or equal to 0. Basically, find the value of g inverse of h at the input x equals 4. How do we do that? Well, we first need to find the composite function g inverse h of x. We go in the function g inverse of x, which is this guy, x plus 5 over 3 squared minus 2, and instead of x, we will now put h of x. So h of x was x minus 2, So this is going to simplify and become x. It's going to simplify and become x plus 3. Okay, and now we have to solve this out. Actually, I don't even have to solve it out. This is my function of g inverse of x, right? G inverse h of x, right? Now I can use this to find g inverse h of 4. And so I have 4 plus 3 over 3 squared minus 2. Let's solve this out. So it's going to be, I have to put a bracket. So it's 4 plus 3 divided by 3 raised to the power 2 minus 2. That is equal to 31 by 9. 31 by 9. I hope this is correct. I hope I didn't do anything wrong over here. Okay, part F says explain why the composite function h g inverse cannot be formed. So why can this not be formed? And see, the reason for that is because this is a composite function. So what's happening is if you have the inner function as g and you have the outer function as h, then see what's going to happen is, what is the domain of g inverse of x? Or in other words, what is the range? What is the range? So if this is the this will be the input values of g, this will be the output values of g, and then the output values of g will be the input values of h, and then h will give an output values. Now the reason why h g inverse of x cannot be formed is because if you look at the output values of g inverse of x, so the output values which are the range essentially, it's these values, right? X has to be greater than or equal to negative 2. So the output values of g inverse of x are negative 2 and greater, right? Are negative 2 and greater. Now those values will be going into function h. The problem is that h cannot take in negative values. H can only take in values that are 0 or greater than that. So if you get negative 2 and negative 1 out of g, you cannot send those input values into h. So output values of g inverse of x are negative 2 and greater. However, these values, negative values cannot be input, cannot be input into the function, the function h of x. Right? So this is the reason why you cannot form this function over here.